Touching on tar spot now, I'm going to get into that update. And again, this is a 2021 update. So for 2022, everything that you will see is prior to 2021, data. And I'm going to get into a little bit of the epidemiology. Some of this was shared by a colleague of ours within Bear Crop Science by the name of Andrea Dolezal. She is a plant pathologist at our Waterman Research facility in Northern Illinois. So just a little brief history on tar spot. Prior to 2015, it had never been discovered within the United States anywhere in the Corn Belt. It was first reported, as you can see, in that northern central corridor of I-39 in Illinois, and then kind of scattered throughout central and northern Indiana. And it was all found in 2015, possibly introduced by a tropical storm and depression that we had come up called Bill. In August of 2016 and 17, we did see it expand into Iowa and Wisconsin, a little bit up in Michigan, but really it was not causing any real issues. It was coming in very late in the season. And then in late June of 2018, we did observe it in a number of other counties at very severe levels that caused some major yield losses in northern Illinois, northern Indiana, southern Wisconsin, and southern Michigan. In fact, if we look at the map today, on the Crop Protection Network, on the Ag Pest Monitor, you'll see the counties that it is infected by and large throughout all of Iowa, Illinois, Indiana, into Ohio, up into Michigan, and into Ontario as well, and Wisconsin, of course. A little bit about the epidemiology of this disease. It's an obligate biotroph. So it can't be cultured. It's difficult to make an inoculum assay so that we can test genetic performance of plant host resistance. Its origin was in Mexico and Central and Latin America. Was first discovered in 2015, as I indicated. And there was a major epidemic of it in parts of the Midwest, upper Midwest in 2018, and again here in 2020. And we saw yield losses up to 60 bushel, some even higher than that if the standability and the quality of the stock went down and we lost ears to the ground. With ear drop, you could have even more significant losses, or if you had a major wind event, that would drop the corn. The environment that it was based on, that we thought was it's an ideal wheelhouse from Mexico data, showed that it liked a more temperate temperature of 60 to 70 degrees, and certainly that was the case when we saw a big outbreak in 2018 in our August timeframe. However, this year I would argue this point. I don't think it really has an upper limit on how hot it can get, and it can still thrive. I think the key is when we have high relative humidity and high moisture in the canopy, as noted by Dr. Nate Klacheski here in 2020. Just like any other disease, it can spread due splash and wind dispersal. Something that's a little bit unique to it compared to other diseases that we see in corn and soybeans is that it has a extended latent period. So from the time that the infection occurs or the spore germinates and gets into the plant till the time that we see the stromata, which is the fruiting body on the leaf surface that creates new pustule or new spores, is a little longer than we're accustomed to. With gray leaf spot, we usually see that latent period be somewhere between 7 and maybe 14 days at the most from infection to actual new lesion creating spores. This disease tends to hang out a little bit longer in a plant before it starts to create the stromata, which are the fruiting bodies, more like a 14 to 21 day latent period. There are many different looks to this particular disease. Most associate this little speck that you see on the left-hand side. Looks just like a little tar spot, like you'd splatter tar on a leaf surface. It's hard to rub off, and if it does, it gets on your thumbnail and doesn't want to come off of it either. Sometimes we see these fisheye lesions, which were very widespread in 2018. We really hadn't seen them prior to that in the United States. So it's a little ring or fisheye around that tar speck. And then in some cases, we get these elongated lesions, similar to like a lesion shape that you would see with a gray leaf spot or some of our other common corn diseases. And as you can see here in these pictures, and especially the one on the right, you can see we might have all three of those symptoms on the same leaf. We can see the elongated tar stromata, you can see the fisheye, and then you can see a singular tar speck. There were several different hypotheses or theories of what is causing this. Could be a reaction by genotype or hybrid reaction to the disease, could be a subspecies or species different within that Phyllochromatus, could be the environment driving it, could be a combination of any of these three. What we do know, and what we thought we knew back in 2015 when it was first discovered in the United States, was that the fisheye and the extreme loss that could occur due to this disease was only associated when we would find this secondary disease called monogrammatis, and that was what was oftentimes hypothesized with why you got the fisheye. And in Latin America, certainly this disease is prevalent, but in the United States, we have not still been able to find monogrammatis in any of our tissue cultures that we've done in any of the previous years since 2015 when the disease was discovered. So the one theory that we can drop off this list is number 4, but the other 3 probably influence why we see different types of spots on the leaf plant. Again, just looking at some other pathogens that might kind of help weaken the plant, things like gray leaf spot, maybe southern rust, fusarium or crown rots. Those things are all diseases that sometimes exaggerate or accelerate the leaf death and dry down, as we saw in 2021 again. Looking at a severity scale, and this is just kind of a computer-generated severity scale showing what 1% severity all the way up to 25% would look like on a leaf surface, whether it was just the tar spot or whether it was the frog eye or the fish eye look. What we've learned right now is when we see leaves within the canopy anywhere from about 2 to 3%, so around this area, we probably need to be spraying a fungicide or may have even missed our opportunity to get full protection from that disease. So it doesn't take a lot to really accelerate this disease when conditions and environment are correct.